So hello everyone, in this video we'll be solving another LeetCode problem, and the problem name is minimize maximum pair sum in array. The pair sum of a pair a comma b is equal to a plus b. The maximum pair sum is the largest pair sum in list of pairs. For example, if we have pairs 1, 5, 2, 3 and 4, 4. So the maximum pair sum would be maximum sum among all of these pairs. So in this, maximum sum is 8, which is nothing but this 4 plus 4. So that's why the maximum pair sum is 8. Now they have said that given an array nums of even length, pick up elements of nums into n by 2 pairs. Obviously, if n is even and we want to pair elements, the number of pairs will be n by 2 only, such that each element of nums is in exactly one pair and the maximum pair sum is minimized. So this question is actually easy. They have marked it medium, but yeah, it is actually easy. So first good thing is that they have provided that nums has even length, so we don't need to worry if nums length is odd, so what we will do with the extra remaining element, and so on and so forth. The another good thing is that they have said that each element of nums should be in exactly one pair. So this is also a good thing for us. We need to only care about like independent pair. We don't need to think that whether we have paired 1, 2, so we can use this one in some other pair such that our maximum pair sum is minimized or not. No, this we don't have to do. So this thing is actually again very good. We just need to simply create pairs and just take maximum among them. And the most important thing is this: the maximum pair sum is minimized. Now what do you mean by this? So let me explain you with the help of this example. This is the main thing: maximum sum is minimized. So what does that mean? So let's say you end up making some pairs. I will explain with example also, but yeah, in general terms, first I'll explain. So these two are the pairs that we make. So 3, 3 and let's say 2, 2. So in this, the maximum pair sum is 6 because this is 4 and among these two, this is 6 is the maximum. So if we make pairs like this, we get the maximum pair sum as 6. But if we make pairs like this 3, 2 and 2, 3, so in this case the maximum pair sum is 5. So previously the maximum was 6, but if we pair something like this, our maximum is 5. So we need to pair in such a way that the maximum is also getting minimized. So this is what they are saying. Even though in this the maximum was 6, but we need to pair such that that 6 should also be minimized. So we paired in such a way that the maximum value is also as minimum as possible, and in this case it can not go beyond or below 5. So this is what they are saying. So let us understand with the help of this second example also, and then we will see the idea or the intuition behind this particular problem. So they have given the pairs as 3, 5. They have given the numbers as 3, 5, 4, 2, 4, 6. So let's say if we pair 6 and 5, we pair 4 and 4, and we pair 3 and 2. So this is the pair. So among these, maximum pair sum is what? The maximum pair sum is this 11, because its sum is 8, its sum is 5 and its sum is 11. So maximum pair sum is 11. But will we return 11? No, the output is 8. So that means the pairs that we have created are not valid actually, because we can get a maximum value as well. So what I am saying, that if I pair something like this 6, 2, if I pair 5, 3, and if I pair 4, 4. So you see, here the sum is 8, here the sum is 8, here the sum is 8. Now among these, maximum is also 8. Now this current maximum is lesser than this previous maximum. So that means we have minimized our maximum value, and according to this question, we cannot go below this maximum value. So our final maximum value that can be minimized is 8. So we are returning the output as 8. So this is what the question is saying. Now let us understand how will we actually solve this particular problem. What is the idea behind this problem? So the most important thing is that we need to minimize the maximum sum or maximum sum of pair. So how we can do this? Now there is obvious thing that if we pair two numbers that are maximum, or let's say second maximum, obviously this will not give us the correct answer, because obviously we are just pairing the two maximum elements. So how can we minimize the maximum element? So yes, we can say that okay, we will not choose two maximum numbers at the same time. Two maximum numbers, I mean maximum and second maximum, or if they are equal then both are the maximum. But can we choose two minimum elements together? Let us see with the help of this example only. So let us take this example, and what are the two minimum elements? Two minimum elements is 3, 2. 3, 2 or 2, 3, whatever. Then the two minimum element is 4, 4. So 4, 4. And then the two minimum elements or the final maximum element is 5, 6. So here the sum is 5, here the sum is 8, here the sum is 11. Now you paired minimum elements together, like you only took minimum elements, but still you didn't get the answer. Why? Because if you pair minimum elements, then in the end indirectly you will end up pairing two maximum elements. So this approach will also not work. So you cannot pair two maximum elements together, because that is obvious. You cannot pair two minimum elements together, because if you pair minimum elements indirectly, in the end you will remaining with only maximum element. So again you will be end up pairing those two maximum element. So this approach is also not good. So how we can do that? Now we need to create a balance between this minimum value and the maximum value. So how we can create a balance between that? So what we can do, we can pick a largest value or the maximum value, and we can pair it with the minimum value. So if we have one value largest and one value minimum, so it will create the balance between them. So it cannot happen that our answer will always be maximum, because in this case, in the previous case, what we have seen, if we take minimum elements, we will end up getting towards the maximum. If we are taking maximum elements, that is of no point. So we need to create a balance that it will remain almost same in every pair. So how we can do that? So we can pick one largest element, we can pick one smallest element, we can pick second largest element, and we can pick second smallest element. So this is how we'll be doing this particular problem. So let me just dry run on this particular example only. So this is 3, 5, 4, 2, 4, 6. Now the constraints of these questions are such that we can apply O of n operations, or we can have the time complexity of O of n, or we can have the time complexity of O of n log n. So here sorting would be helpful, because here we don't need to do anything with the order of the elements, and also if we need to have the maximum element and minimum element, so we need to sort so that we can always get the maximum, minimum, second maximum, second minimum. So for maximum we can just iterate from the back, and for the minimum we can iterate from the beginning. So first of all we will sort this array. So after sorting, the array would look something like this: 2, 3, 4, 4, 5 and 6. Now what we will do, this will be the position for the maximum element, or let us say the j pointer, and this is the position for the minimum element, let's say I pointer. Now for each and every iteration we will make pair of I and j. So the first pair will be what? 2, 6. Then we will go towards the closer elements. Now I is here and j is here. Now the pair will be what? 3, 5. Okay, now we will come more closer element, j. So this is the last pair. So last pair is 4, 4. So here the sum is 8, here the sum is 8, and here the sum is 8. So the maximum value of the maximum sum pair is 8 only, and that is what our output is also getting. So this is the correct approach. Now why this approach is working? Because we are not considering one particular extreme part. We are not only picking the maximum, we are not only picking the minimum, because picking the minimum will indirectly pick maximum elements in the end. So we need to create balance between these two numbers. So we can create a balance by picking one maximum element and one minimum element, second maximum element, second minimum element, third minimum element, third maximum element, and so on and so forth. So it will create a balance between the sum of the pairs. So we will not get a very large value or very unexpected large value. because we are not pairing the extreme things together. So this is the idea. So we can just sort the array and we can just use this two pointer technique to always get the maximum and minimum elements, so on and so forth. So this is how we'll be doing. So let us understand with the help of code how we can code this solution. The time complexity is O of n log n for sorting. Yeah, so this is the time complexity. So let us see the code now. So this is the code. So first I am sorting the entire array in the ascending order. Then I am creating a variable n, which is nothing but the size of nums array. Then I am creating two pointers I and j. I will be picking up the minimum element, j will be picking up the maximum element. This is the answer which I have initialized to int min, because we want to compare for the maximum value. We need to initialize the answer with as minimum value as possible. So I have initialized it with int min. Now we'll be pairing up the elements until I is less than j. So first of all we will get the sum of nums of I and nums of j. This is maximum and this is minimum. So we will get the sum and we will compare what is the maximum pair sum that we have so far. We will compare with that. So if the sum is maximum than this current maximum, so we will just update our answer with this sum, and then we will just move forward with our I pointer towards the right and j pointer towards the left. So we will keep on doing until we pair up each and every element, and in the end we are just returning the answer. So this was the solution for this problem. I hope you understand this solution. Thank you for watching.